Oh, sorry about that. I got slightly interrupted there. Remember, 2 times negative 4 is negative 8, and x times x is x squared. So numbers, then variables. Now we've got negative x cubed, because that's negative 1. Oh, not negative, right? Negative 1 times negative 1. So I even said it to myself out loud, so you might need to just go back and double check these things. Negative 1 times this is negative x squared, and now negative 1 times this is plus 4x. Now, you need to check to make sure these things combine before just assuming, but we can see that, look, I've got an x cubed and an x cubed, so those combine, and I've got an x squared and an x squared, so those combine. So final answer is going to be negative 2x to the fourth. This is a positive because we had a negative times a negative, right? So this is plus 15x cubed minus 7 and minus 8 minus 15x squared. Those are not like terms, so they cannot be combined. Plus 4x. Here's my final answer. And last but not least, this is kind of a pain, but there's no way around it. Sometimes you got to work through the tedious math. And it's good practice to attend to precision, you know, to get all the way through a detailed, complex problem. So if I've got x to the third and x to the fourth, it's x to the seventh. Minus 2, because I don't have a coefficient, so this is just 1, and then I've got x to the sixth, and then I've got 5x to the fifth. We've got 2x to the sixth, because this is x squared times x to the fourth. Okay, so we're not doing an exponent on an exponent. It's just x, 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 x. So there's 6 x's that are multiplied together here. Minus 4 x squared x third is x to the fifth. And plus 5x plus 2x squared. So this is plus 10, and then x squared times x squared is x to the fourth. Now I've got negative 7x to the fourth. I've got plus 14x to the third, and minus 35x squared. So outside is where I started. These are the things that I get, the product, right? What I get by multiplying together. So I'm looking for like terms. Let's see, this is 2x to the sixth, and this is negative 2x to the sixth. Just double checking to make sure that, yeah, x to the third plus 2. So I didn't drop a negative anywhere. So that means that these are like terms, and they cancel out. I know I shouldn't cancel out in the color green, but there we are. Now I've got, look, x to the fifth and x to the fifth terms, so plus 5 minus 4, but not this one. So here I've got this, and that's plus 10 minus 7 is plus 3x to the fourth. And last I've got these, which don't have any to combine with. So there we are. All right, on to page 2. Area of the large triangle is 3 minus x times 3 plus x. So this is dimensions of a rectangle, length times width. Difference of perfect squares. So I'll refer you back to D to how this works out, but basically our two middle terms cancel out, and so we're left with 9 minus x squared. And same with the small rectangle, right? The 1 plus x, 1 minus x. Okay, so this is 1 minus x squared. Again, go back to number 9 if you're not sure exactly what that looks like. This one. Okay, that's a difference of squares. All right, area of the shaded area. So that means I take the big rectangle and I subtract the small rectangle. Well, would you look at that? If I do that, 9 minus x squared minus 1, and then minus a minus is a plus x squared, and my x's, x squareds, cancel out. So that leaves me with 9 minus 1, or 8, which means I don't even have to know what x is. I can get a final answer that's a number. Each page of a book is containing a rectangle that is 5 inches wide by 8 inches tall. So this is 5 by 8. The margins are x inches all the way around. So I've got x, 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 and x. Draw a diagram, then write and simplify a polynomial expression that represents the area of the entire page. So, look, I've got from here to here is 5, and from here to here is x. All right? From here to here is 8, that's where the printing is, and then there's also x here. See how that works? So this means that this is 2x plus 5 by 2x plus 8. So, box method. Combine like terms. 4x squared plus 26x plus 40. Toy rocket is launched from the top of a 4-foot tall table with an initial velocity of 50 feet per second. The height of rocket t after t seconds is given by this equation. So there are basically two variables, the time and the height. So we don't need to worry about the 4 or the 50. They're already involved in here. How high will the rocket be after 2 seconds? So t equals 2. How high will the rocket be? H equals negative 16 times 2 squared plus 50 times 2 plus 4. This is negative 16 times 4 plus 50 times 2 plus 4. So this is negative 64 plus 100 plus 4. So this is going to be 104 minus 64. It's going to give us 40. All right. Hey, we're into review here. Okay, so we're done with the module for the unit 2 material, and now we're going back and recapping it because we want you to retain this stuff. So this is going to be a chance to make up some points. If you did poorly on that first test or you want to improve your score, this is a chance to do that. How do we solve an absolute value equation? We have to treat this absolute value expression right here like its own variable. Like, so if I said this was u and solve for u first. So basically, you're going to say, I'm going to do everything to get that by itself. Then I do that split like this. So we want to get rid of the plus 2. And then we want to get rid of the times 1/2. So we do that by multiplying by its reciprocal, and this is x minus 3 absolute value equals 16. So now we can split it. We can say, well, either x minus 3 equals positive 16, or x minus 3 equals negative 16, because if it equals negative 16, when we take the absolute value, it will turn it positive. So let's add 3. Inequality notation looks like this. Does not include negative 4 because it's an open circle, so we leave that just as it is. But it does include 2, so x is less than or equal to 2, just like that. And interval notation looks like this. Don't include -4, but do include 2. All right, last but not least, last page, graph. All right, remember our vertex form is x minus h plus k, and here's our slope. So here our vertex is hk, so our slope is, so our vertex is 3, right? It's x minus h, so we don't take the negative and call that h because the negative is already there. If this was a plus, then we'd have to make it negative because it would have to be minus a negative. So essentially h is whatever the reverse of the sign is. H and then k, 5, so a vertex is 3, 5. Our slope is -2/3. Now I don't ask you for that specifically, but you're going to need to know that. So if we go 3, 5, we know that it's down 2 over 3. Down 2 or over -3. I think so. So our domain. Oops. Not equal to. All values of x, right? Goes off in either direction. Our range, however, doesn't go up to infinity. It does go down to a negative infinity, but it goes up to 5, and it includes 5. All right, kind of a funny looking function. State the interval over which the function is increasing. So we can see that as we're going from here, it's going lower, right? It's going down, 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 and then it goes up, and then it turns around and goes down. So here's where it's increasing, right? There, increasing. In other words, we're saying that's the interval between 0 and 2. And it's decreasing between negative infinity and 0, so all the way till here it's decreasing, and from 2 to positive infinity. State the maximum value. So we've only talked about local maximum values. So when I get to the test, we're going to make sure that we ask you specifically for local maximum values. A local maximum value means where does it turn around from it's increasing and then it starts going back down, right? That's this point right here. So that point is 2, 1. So this is not an interval, this is the actual point, 2, 1. And state the zeros of the function. Well, there's a 0 here, 0 here, and 0 here. In other words, when does x equal 0? No, excuse me, when does y equal 0, right? When are we on the x-axis? So that's at -2, at 1, and at 3. All right, there's your review. Good luck. Study well. If you get through all of this, and you can do it promptly, not rushing, but if you can just get through it, you don't have to sit there and agonize over these, then you're in good shape. So we'll take the test on Wednesday, and I will see you then.